Hi, I'm Kyle Miller, Solutions Engineer at DJI. Whether you're a surveyor, a construction professional, or an aspiring drone pilot in the commercial field, accuracy is crucial when capturing reliable mapping data. For today's topic, we'll be discussing map accuracy and options to achieve a higher level of accuracy within those maps. First, let's define map accuracy. Accuracy refers to how closely a measurement comes to measuring the true value on Earth. The goal is then to quantify the inaccuracies of the map, giving us the map's spatial accuracy. You may have some overarching questions such as, how do we quantify the inaccuracies? And what other factors might be hurting my map's accuracy? Let's discuss further. You may have heard the terms relative accuracy and absolute accuracy. Well, relative accuracy refers to how accurate a map scaling is. If the relative accuracy is good, accurate measurements can be made between locations within a map. For example, in accident scene reconstruction, having good relative accuracy could be sufficient as you have accurate distance measurements. Absolute accuracy, on the other hand, refers to the degree of accuracy of a map compared to its true value on Earth. For example, if the end goal is to measure the quantity of a stockpile on a single day, a high level of relative accuracy is required, but the location of the pile on Earth isn't as important. On the other hand, to fly that pile again next month and track the change over the time of that pile, a high level of absolute accuracy is required to understand the pile's location on Earth to see if it's changed. Because of inaccuracies of using GPS alone, a great way of improving map accuracy is to use RTK or PPK for GPS corrections. The main difference between RTK and PPK is when you are correcting the data captured. RTK requires you to be connected at all times during the mission for corrections, whereas PPK will log the offsets in the field and the corrections will be done in post-processing. To find out more on how RTK improves absolute mapping accuracy, watch this previous video. With our DJI Enterprise drones such as the Mavic 3 Enterprise with RTK module or the Matrice 300 RTK, we have talked about how you can use an M-Trip provider or a third-party base station with broadcast capabilities to ensure absolute accuracy. Our DRTK2 base station is another option for live RTK corrections. If you need to ensure good absolute accuracy, it's necessary to put the DRTK station on a known point. But if only relative accuracy is needed and the DRTK station will be staying at the same location during flights, it is not mandatory. To set a known coordinate for the DRTK2 station, after connecting the DRTK2 to the drone following our user guide at the bottom of the RTK settings page, you can then tap on Advanced Settings, select GPS coordinate input, and then enter the known WGS84 coordinates and tap Save to confirm. Make sure to offset the altitude of the point on the ground by adding the DRTK2 mobile station height of 1.8 meters with the stock DJI DRTK2 rod. When using a third-party manufactured rod, the height offset needs to be pre-measured. After connecting to the RTK source of choice, if you are still struggling to get RTK fixed due to the drone's satellite reception, it is possible to take off so the drone has better satellite reception and then enable RTK while in the air to get RTK fixed before starting your mapping mission. When planning a mapping mission, many characteristics come into play for accuracy. The mission's altitude will help determine the ground sample distance or resolution of the map. It is impossible to get a higher level of accuracy than the overall map's resolution. Other factors that can hurt mapping accuracy include rolling shutter distortions from the sensor, too slow of shutter speed or mapping too quickly, and insufficient overlap settings. A recent study conducted by Drone Deploy found that the Mavic 3 Enterprise with RTK was capable of inch-accurate survey-grade aerial mapping while a consumer drone lacking RTK and lacking a mechanical shutter was not. This further validates the need for survey-grade drone hardware. Some tips for minimizing inaccuracies included using a mechanical shutter sensor like on the Mavic 3 Enterprise or on the Zenmuse P1, capturing with a fast shutter speed, and flying with a minimum of 70% side lap and 80% front lap. Now that we understand flight characteristics, let's talk about measuring those inaccuracies. The best method for verifying map accuracy is to use ground control points and checkpoints. Ground control points and checkpoints are physical targets that are laid around the site before data capture. These points become the specific locations to see how closely a measurement comes to measuring the true value on Earth. Before the drone data has been captured, a surveyor can use a base station to measure the known location of the center of each target. Just note, this function is not supported by the DRTK2 station and Pilot 2. When processing, the checkpoint's location in the drone map is measured against the reading from the base station, giving us the location's accuracy. Please note, using ground control points will help make a map more accurate, whereas a checkpoint is only used to check against the map's accuracy. GCPs aren't required, but checkpoints are needed to verify that map's accuracy. To learn more about ground control points and checkpoints, check out this blog post. And thanks for watching. Subscribe to our YouTube channel to learn more about the commercial drone applications, best practices, and user stories. If you like this video or if you have any suggestions, make sure to drop a comment in the section below.